All right, guys. So today we are talking about the second half of lesson 6.7. We're still talking about solving radical equations and inequalities, but today we are focused on what do we do when we see not one, but two radicals. All right. What do we do? Okay. So here are your steps. Step one is you want to isolate one of the radicals. Okay, if you see two of them, just isolate and get one radical all by itself. And I usually will isolate the more difficult rad. Okay, so that's my personal preference. I like to isolate the more difficult radical if I had, multiple ones to choose from. Okay. All right, step two is you want to raise each radical to the index, the power equal to the index of the radical, very similar to what we did yesterday, right? So that gets rid of the rad. And what happens is it will typically get rid of one of the radicals, at least one of the radicals. Sometimes you might be still left, though, after this step, you might still have radicals floating around. So if you still have radicals floating around, you want to isolate any remaining radicals, right? And then raise each side to the power again. Okay, because every time you raise to the power, it gets rid of radicals. So you just keep doing that until you have no more radicals, and then you solve. Okay, and then once you're done solving, you will check your solutions in the original equation, just to make sure you don't have any extraneous solutions. All right, so actually really similar to what we did yesterday, but maybe a few more steps. Oh, yes. 6.7 day 2. Sorry if I said something else. But yeah, 6.7 day 2. All right, so let me show you how this works. So number one, we have two radicals, and I think the more complicated one, probably this one, is already isolated. They're actually both isolated. So I can, skip step one where it's already done. I can raise both sides to the power of 2, since that index is 2, it's a square root. And that leaves me with 6a minus 4 is equal to 2a plus 10. All right, so that's cool. Both radicals got taken care of. So I can solve for a by subtracting the 2a, adding the 4, and I get a is 14 over 4, which reduces to 7 over 2. All right, now, before I box it, I have to check. All right, so let's check and make sure that works. So I'm going to plug in 7 over 2 in for a in my original problem. All right, and let's simplify. So this gets me 21 minus 4, which is rad 17. This one gets me 7 plus 10, which also gets me rad 17. All right, so that lets me know that I have a correct answer and I have no extraneous solutions. So that is my final answer. Okay, let me take a pause for any questions. Okay, I'm not seeing any in the chat either. So I will move on to number 2 and see if you guys come up with any questions after that. All right, so number 2. First thing I'm going to do is I'm going to isolate the more complicated radical. This guy definitely looks like the more complicated radical. And the good news is that it's already isolated. He's already by himself, all on his lone self on one side of the equal sign. All right, nothing else with that radical. So I'm going to square both sides. Now, careful when you guys square both sides, make sure you don't do this. I see people do that a lot. That is not correct. You can't square each term like that, okay? You have to square each entire side like that, okay? So square the entire side. And on the left, I'm left with just 3g plus 1. On the right-hand side, I'm going to need to do a little more work. I need to actually multiply that rad 5g minus 1 times rad 5g minus 1. Okay, so let's FOIL this out. So multiply rad 5g times rad 5g gets rid of the rad. So I'm left with just 5g, which also I wish my phone had. And then if I multiply the outside, I get negative rad 5g. Multiply the inside, I get another negative rad 5g. And multiply the outsides, and I get positive 1. Okay, so it looks a little more complicated than our original, but notice we only have, well, it looks like 2 rads, but when we simplify this down, we're only going to have 1 rad left. So that is progress, right? So I'm going to combine those. Let me go ahead and add that to the other side. So I get positive 2 rad 5g. And I'm going to subtract the 3g. So I have 5g minus 3g, giving me 2g. And then I'm going to subtract 1. I'll go ahead and show this so you can see what I'm doing. I'm going to subtract 1, and so that just becomes 0. All right, and then I'm going to divide the 2 because I need to isolate the radical. So if I divide the 2, I'm left with rad 5g is equal to g. All right, let me take a quick breather here to see if there's any questions, if I lost anybody on any of those steps.
Miss Leong.
Yeah, go for it.
So negative 10 rad g or minus rad g10 is the same as 2 5 rad 5g, right?
Oh wait, so negative 10 rad g like that?
I meant like inside, or so the negatives on the outside, and then it's 10 rad g. So yeah, because negative 5 rad g and then minus negative 5 rad g is negative 10 rad g, and but on the third one,
Oh.
3g plus 1 is equal to 5g.
Okay, are you asking if rad like 5g plus rad 5g is equal to rad 10g? Is that what you're asking? Essentially?
Yeah.
Okay, that's a no. Okay. But I know why you're asking that because imagine if I have rad 1 plus rad 4. Is that equal to rad 5?
No.
No, right? Because if I simplify 1, simplify this as 2, this is not equal.
Mm-hmm.
Like, so you actually can't add inside the radical like that.
So on the third line of the equation, when it's 3g plus 1 is equal to 5g minus 2 rad 5g plus 1,
Yeah.
is that minus 2 5g the same as the on the second line when it's like negative rad g5 minus negative rad g5?
Yes.
Okay.
Yeah. So that negative rad 5g minus rad 5g became negative 2 rad 5g.
Okay.
Yes. Good clarifying questions. Yeah. So how I like to think of that is a radical is just, it's kind of like if I have, let me do a different color here. If I have like negative x minus x, that's equal to negative 2x, right? So it's almost like negative something minus the same thing gets me negative 2 of that thing, if that
Okay. Yeah,
clarifies.
that makes sense.
Yeah. Okay.
Yeah.
Good questions. Yeah. Great. Okay. I don't see any questions in the chat yet, so I'll go ahead and keep going. If you have any other questions, plop it in the chat, and I'll be happy to answer anything. Okay. All right. So we have rad 5g is equal to g. So I'm going to square both sides to handle and take care of that last square root, giving me 5g is equal to g squared. Now, the temptation sometimes is, ooh, let's divide g. You don't want to do that because you actually throw away an answer if you divide by the variable. So my kind of rule of thumb is I never divide by a variable. I only divide with numbers, okay? So instead, I'm going to subtract the 5g over and get one side equal to 0. Right? I do that anytime I see my variable squared. I have quadratic because I can factor now. And when it's equal to 0, I can solve for g. So g will be equal to 0 or 5. Okay. All right. So now let's check our answers and see if both.
Wait, how did you just get 0 and 5?
Oh, sorry. So here, when I have g times g minus 5 is equal to 0, either this has to equal to 0 or this has to equal to 0 for that to multiply to 0, right? So then you get g is 0 from this one, and you get g is equal to 5 from this one.
Oh, okay.
Do you kind of remember that, Michael? Like if you have x minus 2 and x plus
Yeah, I remember
3.
that.
Yeah, so it's like that. Okay.
Okay.
All right, cool. So let's do our check and see if any of these guys work out. All right, so let's plug in 0 and remember in the original equation. So I have square root of 3 times 0 plus 1 is equal to rad 5 times 0 minus 1. So I get 0 plus 1, which is rad 1, which is 1. And then rad 0 minus 1, ooh, gets me negative 1. So this one does not work out. So got to take out this answer of 0. Okay, well, that didn't work. Let's check the other one. Maybe that one will work. So let's check 5. So I do square root of 3 times 5 plus 1. See if that's equal to 5 times 5 square root minus 1. That gets me 16, which is 4. That gets me rad 25, which is 5 minus 1. So that equals to 4. All right, so that one checks out. Awesome. So one of them worked, which is great. So I have a final answer then of g is equal to 5. Box it. Final answer. Okay, any questions? Put it in the chat or unmute yourself. Cool. All right, then. Let's try number 3. Okay, and let's see if I can get somebody to help me with this one. All right, and I might be calling on multiple people throughout the entire problem, so make sure you're keeping track with where we're at. Okay, Queenie, start us off. What would you do first if you were given a problem like number 3?
I think I would square root both sides. Not square both sides.
Okay, good. I was like, if you square root both sides, oh man, that's gonna be tough. All right, good. Square both sides. All right, and what do we get?
I will get 2 minus x minus 2.
Wait, 2 minus. Oh yeah, say that one more time.
2 minus x minus 2.
2 minus x minus 2, like that.
I think so. Oh wait, no. It is 1 minus.
It actually, okay, so be careful. I think what you're doing is you're squaring the 1 and then you're squaring, like, you're like distributing the square, right? Careful, you actually can't do that. You have to FOIL it. So I would rewrite it like this so you remember to FOIL it out.
Okay.
Okay? So what happens on the right-hand side?
It will just be x minus 3.
Good. Okay, so FOIL it out and let's see what we get. So 1 times 1.
1.
Good. And then 1 times negative rad x minus 2.
Just a negative rad x minus 2.
Good. All right. And then this one, negative rad x minus 2 times 1.
Still minus rad x minus 2.
Good. And then the last part, those two multiplied.
Plus x minus 2.
Perfect. Good job. Okay. Let me switch over. Good job, Queenie. Let me switch over to Luke. All right, Luke, what do we do from here?
Oh, well, we can combine the negative square root x minus 2 to get negative 2 times the square root of x minus 2.
Good.
And then we can get rid of the 1 and the 2.
Mm-hmm.
So the negative 2, we add 2 to the other side. And the positive 1, we minus 1. So we just plus 1 on the other side. So it'd be x minus 2 on the other side.
Okay. Sorry, that was a lot.
Yeah.
Let me subtract 1, add 2, right? So subtract 1, add 2. Okay. And so what does that leave us with?
X minus 2.
X minus 2. Okay. Oh, and then what about the x here?
We can subtract the x. That way it's just negative 2 that's left.
Nice. Okay. So negative 2 is left. These x's subtracted out. And there we go. All right, keep going.
Then we can divide it by negative 2 on both sides.
Good.
Then we get the square root of x minus 2 is equal to 1.
Nicely done. All right, Luke, thank you. Okay, let me switch over to Jaden. All right, Jaden, what do we do from here?
You have to plug in the... Oh.
Not ready to plug in yet. Haven't solved yet. So how do I keep trying to solve for x?
You square root it.
Like that?
I mean, square it.
There you go. All right. You and Queenie doing the same thing. All right, square it. Good. And what happens on the left?
So then it equals x minus 2 equals 1.
Perfect. All right, and finish it off. X then is equal to
1 over negative 2. I mean negative 2.
Oh, wait, hold up. So x minus 2 is equal to 1. I need to do what to both sides?
Oh, add the 2.
Yeah, add the 2. So what do we get?
3.
Good. All right, and then you were saying before, I can't just stop here, right? What do I need to do?
Then you plug it in.
Good. All right, so let's check it. And I'm going to plug it into the original and substitute 3 anytime I see x. All right, so then what do I get? I get 1 minus.
Square root 1.
Uh-huh. All right, and that gives me
1.
good. And then 1 minus 1 gets me
0.
nice. All right, and then what about this right-hand side?
Then that equals 0.
Good. So does it work out?
Yes.
Yes, it does. So what's your final answer, Jaden?
3.
Good. All right, guys, that is our final answer. Nicely done. X is equal to 3. Checked it. Worked out. We know we're good. Awesome. All right, let me take a pause. Any questions on that one? All right, so number 4. This one's a little bit different, guys, because notice it's an inequality. All right, you have a greater than 0 sign there. So this one's going to be a little bit different, actually more similar to what we did on our last lesson. Okay, so the first thing I'm going to do is I need to make sure that since I have this inequality here, I got to make sure anything inside the rad is greater than or equal to 0. Okay, so this first one, I'm going to make sure whatever's inside that first radical greater than or equal to 0. I'm also going to make sure that anything inside the other radical is also greater than or equal to 0. Okay, so anytime you have any radicals with an inequality, just make sure those are greater than or equal to 0. All right, so let's solve for that. And I get h needs to be greater than or equal to negative 5 over 2. And h has to be greater than or equal to negative 9. All right, so that's my first step. Make sure any radicals are non-negative. Okay, and then my next step is to actually solve for the inequality here. All right, so I'm going to have I'm going to isolate my more complicated radical. So I'm going to move and add that rad 9 plus h onto the other side. Okay. Then I'm going to square both sides. So I get 2h plus 5 is greater than 9 plus h. I'm going to subtract the h, subtract the 5, and I get h is greater than 4. All right, let me take a pause. Any questions so far? All right then, number line time. So let's go ahead and set up our number line. And this time I have 3 marks to make. One at negative 9, one at negative 5 over 2, and one at 4. All right, so let's go ahead and this first one I have is, oops, wrong number, negative 5 over 2, and greater than, so shading to the right. Okay, this next one is at negative 9, solid dot, shading to the right. And then this last one, we have h is greater than 4, so then this is an open circle, shading to the right. And now you guys need the piece. Your final answer is going to be where all 3 overlap, right? It has to be all 3 overlapping. So that's only at this spot on the number line and an open circle at 4, since we have an open circle here. So your final answer is h is greater than 4. And that's your final answer. No need to check. All right, and that's how you handle an inequality when you have more than one radical. Okay, any questions? Go ahead and put in the chat or unmute yourself. All right. So we usually don't have enough time to get to the word problems, but I think we have time today. So let's jump straight to the word problem and then we'll go back for number 5. All right, so we have this formula, all right, given to us, represents the swing of a pendulum. All right, where S is the time in seconds and L is the length of the pendulum. All right, and they want us to find the length. All right, so that means we're looking for length of the pendulum that makes one swing in 1.5 seconds. All right, so that tells me that S is 1.5. All right, so let me go ahead and call on somebody and see if you can just help me out with this one. So with that, Raheel, what are we going to do to solve for that L? What do you think?
To find the, would you like square the term?
Well, before that, let's use the formula, right? But let's plug in what we know. So what can I plug in?
The S is 1.5, so you can do 1.5 equals 2 pi, and then 1 over 32.
Good. Oh, that's an L.
Oh.
Yeah, no, it definitely looks like a 1. I'm with you. Okay, so now we have to solve for L. So what do we do?
I think now you square the square root.
Not yet. So you don't want to square until the entire root is isolated, meaning it's just all by itself. So right now, what is kind of crowding with the rad?
The 32.
Well, the 32 is inside the rad. So that rad is one piece. So what else is with it?
2 pi.
The 2 pi. So how do I kind of get that to the other side?
Would you divide the 2 pi?
Yeah, there you go. So let's get that rad by itself. Divide the 2 pi. Perfect. Now the rad is all by itself, right? I just have the radical. So what can we do now?
You square it now.
Yeah, now you can square it. All right, so what does that do? So this I'll just leave as this squared, and then what is left on the right-hand side?
I think it's just L over 32.
Good. Okay, and then to solve for L, what is one more thing then I have to do to solve for L?
Multiply it by on both sides.
Good. By
32.
Perfect. Nicely done. Okay, and that solves for L. So L is going to be 32 times 1.5 over 2 pi square, which of course you would have a calculator. Don't worry, you would not need to do that in your head or on your own. And that gets you 1.82. And I think this is feet. Yeah. Great job, Raheel. Nice. Okay, and that's how you do a word problem. So look at the variables, see what they give you, plug it in, and solve for what you need to find. All right, great job. Let's finish this off with number 5. All right, so number 5 is actually kind of a review problem from yesterday. Notice we only have one radical, and it's an inequality. So let me see if I can get help on this one from Colby. All right, Colby, start us off. What do we do?
We're gonna isolate the radical.
Nice.
Tell
me what to write.
So then we're gonna square both sides. So then it's 3f plus 9 minus 2, and then like you square all of that.
Oh, wait, go back. You said isolate the radical first, though, right? So what do I need to do to isolate the radical?
Get rid of the rad.
Okay, so isolate the
Oh,
radical.
move the 2 over.
There you go. Yeah, so here's my
Okay.
radical. He's not by himself. So yeah, let's move the 2 over. And then what does that give me?
Rad 3f plus 9 is less than or equal to 9.
Perfect. Okay, now go ahead.
And then square both sides.
Yep. Mm-hmm.
And then you get 3f plus 9 is less than or equal to 81.
Good. Keep going.
Move the 9 over. So
Good.
then it's 3f less than or equal to 72.
Good. Nice.
Divided by 3 on both sides. And I think that's 24.
I think yes. Somebody verify. Okay, yeah. All right, good. Okay, now so far so good, but this is actually only half the problem. What else do we need to do?
Check it. Plug it back in.
Not for inequalities. You don't actually have to plug it back in. There's something else, specifically inequalities, we have to make sure to do. And we did this with number 4 on the front side, if that helps.
Graph it. Or put it on a number line.
Before we graph it, it's actually step 1.
It's not set both sides equal to 0, is it?
No, it's like this step right here and here. What did we do there? This is number 4. What did we do?
Well, I don't know like how to put it into words, but like you take one side and then you put 0 on the other.
Kind of. So basically what we're doing is we make sure that whatever is inside any radical has to be greater than or equal to 0. You see that on the screen?
Mm-hmm.
Yeah? Okay, so try doing that with this one. So what needs to be greater than or equal to 0?
3f plus 9, but is the question, is the negative 2, or is like is the negative 2 included or no?
Well, is the negative 2 in the radical?
No.
No. So then no. So it's just whatever is inside the radical has to be greater than or equal to greater than or equal to 0. Does that make sense?
Mm-hmm.
Yeah. Okay. So from
Yes.
here, go ahead and solve that.
3f plus 9 is less than or equal to 0, and then you move the 9 over.
Okay. You said less than, but I hope you meant greater than.
Greater than. Yeah.
Okay. Okay, keep going.
And then you divide by 3 on both sides.
Good. All right. So we get f is greater than or equal to -3. Okay. And now we do the number line. Okay. So number line. We have 2 numbers. One is -3 and one is 24. Okay. So for the first one, I have a solid dot at 24 and then shaded to the left as it's less than. And then this one is a solid dot at -3 going to the right because it's greater than. So what is my final answer, Colby? Where do I want, or where's my answer going to be?
Between -3 and 24.
Good. All right, so where they overlap. Now solid dots, open dots, what do you think on -3 and 24?
Solid.
Good. All right, so what's your final answer? Colby, what's your final answer?
Sorry. F is greater than or equal to -3.
And
Less than or equal to 24.
perfect. There you go. You got it. Way to go, Colby. All right. Sorry, I meant to call multiple people, but you seem like you were on a roll. So I just stuck with you. All right. Good job, guys. Any questions? Go ahead and put it in the chat or unmute yourself.
I have a question on the homework.
Ooh, okay, go for it.
I don't know if